Welcome back. So still on complex number. Now we're going to polar form of complex number. Polar form of complex number. Now, let's just prove a formula before we solve just one example. Let's just prove a formula before we solve one example. Now, given that we have z is equals to x plus iy. Now, let's say we have z is equals to x plus iy. Now, let's first draw the Argand diagram. Let's draw the Argand diagram of how it looks like. Now, this is our y-axis. Right? This is our x-axis. Now, okay, so when we trace it down and we trace it like this, right? So this is our y, this is our x. Now, if this side is our y, then definitely this side is also our y, right? So this is our x, then definitely this side is also our x. But we just only need this triangle, this right angle. Now, this is our angle theta. This is our argument. So the angle must make with the horizontal. Then why this will be our what? Our magnitude r. Our magnitude r. Now, this is just the Argand diagram representation of this complex number. Now, let's prove one formula. We want to prove different types of formula actually, but we want to arrive at one particular formula exactly. Now, when we have this is the angle theta. Let's just name it the name theta. I'll tell you the name at the end of the video. Now, from the word SOHCAHTOA, SOHCAHTOA. From this SOHCAHTOA, now this angle theta, which among these goes along with this side and this side, with this angle theta? Now, is this so? Is it ka or is toa? Now, this angle theta, which one goes along with this side and this side? You know, we have Cartesian coordinate and polar coordinate. Cartesian coordinate are the x and y. Cartesian coordinate deals with the x and y. While the polar coordinate deals with what? R and theta. Cartesian deals with x and y. Polar deals with what? R and theta. Do you understand? So we just want to prove the formula before we solve example, because you can be given complex number in form of Cartesian coordinate and you are told to convert to what? Polar coordinate. Or you can be given complex number in form of what? Polar coordinate and you can be told to convert it to what? To Cartesian coordinate. Don't forget, Cartesian coordinate is in form of x and y, while polar coordinate is in form of what? R and theta. Now, let's prove. So, this angle theta, which out of SOHCAHTOA, which one deals with this y-axis and this x? Which one deals with it? Now, is it so or ka or toa? Don't forget that the side facing your angle is called what? Opposite. The side facing your angle is called opposite. Why the base of that angle, the side that contains the base of your angle, is called what? It's called the adjacent. So this is opposite to this angle, while this is adjacent to this angle. So which one am I taking? That's what? Toa. Opposite and adjacent. So meaning that what? I'll say tan theta will be equals to, now, you know tan is what? This is opposite, right? Why this is adjacent? Now, what is the opposite side of this angle? Which is what? Y. Then over, what is the adjacent side? Which is what? X. Do you understand? So please keep this formula. So meaning that if I'm to look for theta, theta will now be equals to what? Tan in, you know, when you take tan to the other side, when it cross, it changes to tan inverse, right? You know, it's just like dividing both sides by tan. Then that will be over tan. So when you have over tan, it's just like saying tan inverse. So tan inverse of what? Y over x. So keep this formula. Put it in your head. Now, the next one we have to go for now. Let's go for R. Let's go for R. Now, look at this R. What deals with this y and x if you have to look for R? Don't forget, it looks like something like this, right? This is R, this is y, this is x, right? Now, you know, this is a right angle. And what do we use? We use what? Using what? Using Pythagoras theorem. Don't forget, using Pythagoras theorem. And what does Pythagoras theorem state? It says the hypotenuse square, right, is equals to opposite square plus adjacent square. What's our hypotenuse here? That's the longest side, right? So that would be what? R square equals to, that would be x square plus y square. So if I'm to look for R, what will I do? I'll take the square root of both sides. So that will be R equals to square root of x square plus what? Y square. Keep this formula. You understand? Now we've gotten all the old formulas for what? We've gotten the formulas for the polar form, which is R and theta. We've gotten for theta and we've gotten for R. Now let's go. What if we are given in what? In polar form and you're told to convert to what? Cartesian form. Now you're told to convert to Cartesian form. How do you go about it? Now that one is also very simple. Now this angle, why this side and one of the what? And one of the argument, one of the polar form, which is R. Now from SOHCAHTOA, this angle, what goes along with this angle and this side and this side? This is what? Don't forget this is opposite, right? Opposite to this angle. This side facing this angle is opposite. Why this longest side is what? Hypotenuse. So what is that? That's so. Opposite hypotenuse. So that's so. So what are we doing? So what will that be now? Let's put it here. That will be sine theta will now be equals to what? Sine theta will now be, what is the opposite? Opposite is y. Over what is the hypotenuse? Hypotenuse is the longest side, which is r. So when you cross multiply, that will be y is equals to r sine theta, right? You know, this is just like over 1. Y multiplied by 1 is 1. So that will give us y equals to r sine theta. So keep this formula. You can call this equation 1. Now let's go again. For this angle, then this x and this side. Don't forget this is the adjacent of this angle. Why this is the hypotenuse? So that is what? Car. So that will give us what? Cos theta will now be, what's our adjacent? You know cos is adjacent over hypotenuse, right? What's our adjacent? That's x over, what's the hypotenuse? R. So when you cross multiply, that will give us x equals to r cos theta. So you keep this formula. You can call this equation 2. So meaning that if you are given in polar form and you are told to convert to Cartesian form, these are the two formulas you use. But if you are given in Cartesian form and you are told to convert to polar form, what we use, these are the two formulas you use. Do you understand?